Okay, let's start.
Yeah, let's
Um,
let's start our workshop.
okay. Hello everyone. This is Sam from New Smart Economy. Today we are glad to invite Anna to give a workshop again, which called dApp Backend in Go. Hi Anna, you can introduce yourself first and start your workshop now.
Thank you, Sam. Hello, everyone, and welcome to our second workshop about dApp development for new ecosystem. And I'm glad you're here. And my name is Anna. Uh, for those who wasn't present in the last workshop, currently I'm a software developer in the NEO St. Petersburg Competence Center, and I'm here for over 3 years. What we are doing here is mostly working on the NEO node implementation written in Go programming language and a lot of other related and useful components of the NEO ecosystem written in Go, like consensus node, RPC node, CLI tools, and a lot of other useful things. And I think that's all about me, and let's talk about our workshop. Today we are going to talk about dApp development using the whole set of instruments NeoGo provides. But firstly, I would like to tell a couple of words about our previous workshop. And in our previous workshop, we have discussed how to build, debug, and deploy and invoke NEO contracts written in Go programming language with the help of NeoGo. And you can find the record in the YouTube, but the last 15 minutes of this video were cut off. So I'd like to repeat, to mention a couple of NeoGo tools that can help you in the contract development one more time. The first one I'd like to mention is our testing framework. With NeoGo, you can not only write and invoke contracts, but also create unit tests for them. And this framework is called NeoTest. Let's see how it works in the example. We have a set of tiny examples that demonstrates how to use NeoGo to develop your contracts. And let's take a look at the NFT token example. You can find it in our GitHub, in our NeoGo repository. And I have it locally on my local machine. And here the example I'd like to show you is the NNS contract. It's quite a simple contract. It also has some methods, some NEP 11 that complies NEP 11 standard. And to test it, you can use the NeoTest framework. And this is the example of a simple unit test. And what is done here is we create the client, and what it is. The client actually is a testing chain. It is the running blockchain node, a single node in our case, but it can also be, for example, 4 nodes setup or anything else. You can configure it. The NeoTest is a very powerful tool that can be configured. And you create an executor that will build transactions for you, that will sign these transactions, that will add new blocks to the chain, and all of this NeoTest can do within a single unit test. And NeoTest also can compile your contract for you, just specify the source path and the configuration path. And you can also deploy the contract to the chain using neotest, using this executor, and perform some contract invocations with different signers. Here, for example, we use the committee signer to invoke the price method, for example. Yeah. And now, after we have created all of these things, we can just simply run, create an account, and run some methods of the deployed contract. So this is failed invocation. You can see that you can test in the invocation of method that should fail. For example, because of the method, the transaction isn't witnessed by the committee, and you can check the exact exception message that will be thrown by the virtual machine. And you can also perform some successful invocations and check the resulting stack. For example, here we expect that the resulting stack contain default price. Yeah, we request get price method. And so on. So you see that the whole test doesn't take a lot of space. It can be easily reproduced by anyone, and it's just a simple Go test. Yeah. So I really recommend you to use neotest to test your contracts. And another thing I'd like to mention is extremely useful for inter-contract interaction, and this is NeoGo bindings generator. Also, neotest package is a standard Go package. It's well documented. Just go to the package go dev and to the neotest page and see what's there. Yeah, and back to the bindings generation. Our compiler, NeoGo compiler, has the ability to generate contract bindings. Contract bindings is basically the thing that allows you to invoke some deploy contract from another contract, and bindings generator gets the deployed contract information as an input. For example, in this case, it's manifest, or it may be manifest and additional binding configuration. And as an output of the contract generate wrapper command, you can get the generated binding that you can use from some other contract, like an API to the deploy contract. And let me show you an example. The last time we have discussed token contract, if you remember, the token contract is a simple NAP17 token that has methods like symbol, decimals, transfer, of course. And we can generate bindings to use this to invoke this contract from some other contract. And firstly, to generate bindings, we can compile this contract, of course. And it can be done with NeoGo CLI. I probably should mention that you can download our latest release from our release page. It's here on the GitHub, available for you, and the latest release is Jackiness. Here are binaries for Linux, Darwin, and Windows. So just use any appropriate binary and compile the contract. And today I will use the local project. NeoGo is built here. And let's just compile our token contract one more time to see how bindings can be created. Don't hesitate to use help it always has relevant documentation. And here, while compiling the contract, you have to specify additional bindings flag. The rest of the comment is the same as we have discussed in the previous workshop. And the bindings flag points to the output configuration for the bindings. Let's just use some token bindings YAML. Yeah. And let's generate the bindings for our token contract. This comment accepts configuration that was generated during compilation. It accepts manifest as far. It also accepts the output flag. Does it features the and the hash value, the hash of your contract. I think it will show if anything. Yeah. And now let's see what has been generated. The output file is tbindings.go. And here is the binding file that invokes the methods of our contract. You see that I didn't provide the hash. It's because our token contract wasn't deployed to the chain yet. And I just don't know what's the hash of this contract. But you will probably know it because the bindings will be generated for the deployed contract. And basically, we see here all the methods that the contract has, all the exported methods that are declared in manifest. And there is not a lot of them, but they're here. And you can use them, for example, from some other package to just to show you how it will be performed as was package token contract. Yeah, the Golang shows me possible methods. For example, we can invoke token contract balance off and just specify the holder address, and it's pretty easy. Yeah, the bindings generator allows you to avoid this manual work of copy pasting the contract methods and creating these bindings. So use it while developing your contract. And now I also would like to show you some more complicated examples. These token example is quite simple and doesn't have a lot of methods, but in a specific def repository we have NeoFast contract repository, and it contains a lot of quite complicated contracts. They are kind of proficient level, but you can take a look at them. You can just see how the contracts can be built, and we use them in NeoFS in the running decentralized application that is built on the top of Neo ecosystem. And you can just show how to organize your code if you need some more complicated contracts, or you need an example of how to use the NeoGo instruments to build your contract. Yeah, and for this contract, we can generate bindings. I also have NeoFS contract repository cloned on my local machine, and let's generate the bindings for this contract. We have a separate make target for it. I have to specify the binary, the local binary, just because I use master version of NeoGo, but basically we don't have to specify this. And here you can see what happens. Contract generate, contract generate wrapper command is called for all of these contracts. Generate RPC wrapper is another command that we will talk about later. And let's take a look at the resulting wrappers for NeoFast contracts. For example, here we have alphabet contract. It also have a set of methods, some on NAP17 payment, some exported methods that are included into contract manifest. And the resulting binding is stored, let me see, in the bindings folder for alphabet contract. Yeah, and here we have the contract binding. Now you can use all of these methods like from some other contract, like a standard Go package. And well, that's all I'd like to show you from the last workshop, and let's just move on and move to the main topic of our workshop, the dApp development for Neo ecosystem with the help of NeoGo tools. And well, let's take a look at our main page. Everything that you need for dApp development is in the NeoGo repository in our single binary. And the last time we have discussed mostly the CLI tools, smart contract compiler, and smart contract examples, everything that needed for smart contract development. And today we are going to discuss mostly the RPC node and client part, because your dApp is likely to be interacted with the Neo blockchain node, either to retrieve some information from it or to put some information into the blockchain. And today I'll show you all the tools NeoGo has to make this interaction extremely productive, efficient, and time-saving for you. So basically, to interact with the Neo node, your dApp needs an RPC client, and interaction will be performed via RPC node. Let's take a look at this documentation, what we have here. Each Neo node has ability to run the RPC server. The RPC server can be from the C# node implementation or from NeoGo implementation, but all of them are united under JSON RPC specification. And this specification, well, NeoGo tries to follow this specification as close as possible. And everything that is described here is everything that is supported from this specification we have in our documentation. Here are the methods that our RPC service supports, and additional notes about some about implementation of some of these methods. And Neo has its own JSON RPC specification. It's in the docs.neo.org website. Here, all the available methods, all the API is properly documented, and C# node and NeoGo node support this method. Yeah, and let's now take a look at our workshop today. It will be, let me show you the workshop page. Yeah, here it is. Today, we will be discussing an example of simple dApp that uses RPC client, NeoGo RPC client. The dApp is written in Go programming language. You can find it in our workshop, but it is not merged. It is in the pull request stage. And I have this example locally. Let's take a look at it. Yeah. Here's our dApp, and I will demonstrate you all the possibilities that RPC client and NeoGo packages provide you to interact with the RPC node. First of all, we will run a private network node with RPC server on it to be able to interact with some RPC server. Of course, we can use any other Neo node from, for example, from mainnet or from testnet, but for mainnet you need some real gas to push the transactions on it, and for testnet you also need the testnet gas. But here I will show you how to do it in the private network where you own the whole network gas. And let's build and run a private network. The steps are the same we performed in our previous workshop. Take a look at it and just make a single runs a single private network for you, single node private network. Here are the logs. The blocks are accepting, and the height, there's some height, well, 12, okay. And now we have to create a wallet to be able to interact with this node and to perform transfer to the new account. Let's do it. Here our wallet, here our address, and let's dump the private the validator address from our running RPC node. Here is the owner of all fumes, so gas and neo in our private network. And let's perform transfer. Yeah, here's our transfer transaction, and now our newly created account has some gas. Let's query the transaction state to be sure. We have to specify the RPC endpoint. Yeah, here's the transaction is on chain and the transaction was successfully invoked. And now we have everything to start our dApp, and let's take a look at it. And first of all, our dApp creates a simple RPC client. RPC client is a package that implements a neo-specific JSON RPC client that interacts with RPC neo nodes. It can interact with neo node or with a Go node, but Go nodes has some advantages, some additional functionality that isn't provided by the C# node, some extensions, and they are extremely useful. So we recommend to interact with Neo-Go node. And the RPC client is a package that is properly documented. You can find the documentation at package.dev. Just take a look at it. All these packages are described here. The client functionality, the supported RPC methods, some extensions, unsupported methods are also described here, and the index of the whole set of supported methods by our client. And to create the client, you need to provide some context. It can be cancelable context. To be able to cancel some requests, for example, you can provide, you should provide RPC endpoint. It's the same as we have used with our Neo-Go CLI. And you have to provide RPC options. It can be the defaults, like here, or you can provide some additional options, non-defaults, I mean. Yeah. Basically, it's a place for TLS to enable HTTPS connection, and some tuning request parameters. Yeah. And after this, this function returns an error, if so. And to check this, I have a tiny helper. This helper just checks that if error is not nil, it panics. Yeah, to be sure that everything is okay. I have added these checks here, and our client has close method that should be called after everything is done with the client. Basically, is just close the underlying connections, and that's all for HTTP client. Yeah. After that, you can see that the client can be initialized. What it is done, what it does under the hood, it basically requests the node version. It is connected to, it requests a set of native contracts, some information that can be cached. For example, the network, the magic of the network that we can use to sign the transactions, or some additional information. And well, you have to initialize the client if you are going to interact with the network afterwards. Otherwise, some requests will return an error. So pay attention to it. And now let's take a look at the methods that are provided by our client. First of all, these are simple RPC methods that are specified in the JSON NEO specification, and that are supported by our nodes, RPC nodes. And you can also find the documentation for it in the package go.dev. And for example, we have get version method. The server will return, for example, the node version, the user agent, and some protocol values that you probably have to know for to build your dApp to, for example, these are address, some protocol settings like network magic, one more time, milliseconds per block, and etc. etc. Yeah. Well, you by using this request, you can define is it a NeoGo server you interact with, or is it C# node? NeoGo nodes, you have the NeoGo prefix as the user agent, and you can filter out them. And after this, another simple method that can be useful for you is get the current block count, get block count. It just returns the number of blocks in the network. Another useful method is get block by index. It returns the specific block from the chain by specified index. And here is the note that we should pay attention to the block and block index, to the block index and block count conversion. Yeah, block index is block count -1. Well, get block by index returns block, and here we are requesting the current block. And return transaction verbose returns the transaction that is currently on chain. Yeah, the transaction has some fields. The result of this method is transaction output row, and well, everything that in some additional transaction method data that can be useful. And as you can see, the result of this method is located in the Neo RPC package. This package is also well documented, and the documentation you can find in the package go.dev, as for other packages. And here, basically, we store the results of all available RPC methods, and client use these structures. Yeah. After this, we have another very useful method that allows you to get block by hash. And for example, here we can retrieve the hash of the block when our transfer transaction came in. The transfer transaction hash is stored as a variable, and by the way, I have to store this hash here. Yeah. And what else the client can do? It can retrieve application log, the result of your transaction invocation, with the specified trigger. Trigger is application in our case. We have different set of different triggers. The Shargon has explained it in his workshop, and it's on persist and post persist. These are triggers that are used while running the block persisting scripts. Verification trigger is used mostly during transaction scripts verification, and application trigger is used during transaction scripts running. Yeah. So here we have to retrieve application log for our transfer transaction and with the application trigger. As you can see, a set of application logs can be retrieved, a set of executions if there are multiple of them. And we can just, for example, check the state of this execution. We can check, you can see what Golang offers here. We can check the stack. We can check, for example, gas consumed during transaction execution, some events that were emitted during this transaction execution, and as far as this transaction was transferring the transaction, the events would likely be transfer. Yeah, and a lot of useful information you can use to retrieve the status of your transaction in your dApp. Well, and we also have a set of other very useful methods that are specified in the Neo.json specification: invoke contract verify, invoke function, invoke script. All of them allow you to invoke something on the blockchain to perform test invocation. Yeah. We have some deprecated functionality as far. This deprecated functionality is not recommended to use and will be removed in some future versions. You can find the scheduler for deprecated code removal in our docs page. And instead of this deprecated functionality, we have a set of improved packages. I will talk about them later. We have send raw transaction methods as far. It allows you to send the transaction to the blockchain, and we have submit block, submit some payloads to the network, so you can use your client to submit some payloads to the node. We have some iterator-related methods in our RPC client, and some, a set of other very useful methods: get block, get transaction, get something else, get committee. So just take a look at the documentation, and I think that you will find everything there. And also, our dApp is likely to be using the wallets. And to work with wallets, we provide you a separate package. It calls wallet package, and you can find the documentation at the package code dApp. Here are the set of methods that you will use to work with wallet. For example, to open your wallet, to read the wallet from file, to add an account to the wallet, to get some account, to decrypt the account. Yeah, here are a set of methods that you have to use to work with wallet accounts. You can create a new account from some various set of inputs. You can decrypt and encrypt account, and basically here is everything that you need to work with your accounts. And of course, here are a set of special methods that you will use to sign the transaction or to sign some hashable items, for example, to sign some payload or everything that can be hashed. Yeah. And a set of other methods that you will probably won't use so often, but they are here. And now it's just a simple demonstration of the way how you can read the wallet from some file and to retrieve an account from it, to decrypt it, and to sign some transactions afterwards. You will use new wallet from file to read wallet, and the wallet path is read.json. As you can see, it's those wallet that we have created earlier. It's here. It lies under NeoGo folder, and just use new wallet from file to retrieve it. The resulting structure has some fields, and mostly the most interesting one is accounts. It stores all of the accounts that are stored in the wallet, and currently we have a single account inside it because we have created it. And well, you can also get an account, for example, by hash, if you know hash of your account, or to use something else from these methods. Yeah, Golang offers all of them here. And well, here we use account decrypt method to decrypt your account with the passphrase. Account passphrase have to be provided to the decrypt, and it's just an empty passphrase because I wanted to simplify the wallet creation. Yeah. And the second parameter to decrypt is script. Is the parameters that were used to encrypt your account, basically to encrypt your private key. Yeah, these parameters are stored in the wallet, and just use them from the wallet structure. And after you have used account decrypt, your account is decrypted, which means that private key stored inside your account is there. Yeah, you can retrieve it, and you can sign something with this private key. You can sign some hashable item. Here, yeah, I have already said that account has a lot of different useful methods on it. For example, you can create a multi-signature account from, for example, simple single signature account. For example, if we'd like to create a 3 out of 4 multi-signature account, we have to specify a set of 3 out of 4. The set of public keys for this multi-signature, and yeah, just specify. And well, account has a contract. The contract stores a script that can be well, the script can be either simple signature, either multi-signature, or maybe some contract script if it is contract-based account. So just you can use it to send, basically to send appropriate things. Yeah. And after this, our dApp probably would like to use some extension methods offered by Neogo RPC server. Here we have a set of extension methods in our docs on the GitHub page, the GitHub repository. These extension methods are well documented, and for example, this getBlock system fee returns the system fee of all transactions included in the specified block. And for example, the historic functionality, which allows you to provide some historical state to the RPC node. For example, some previous block height, for example, 10. And after that, you can invoke some script or invoke function of a specific contract or invoke verification method of the specific contract at the specified height. And this is basically what historical call is. Afterwards, you will receive the execution result. You can explore it. And also we have submit notary request, but this is kind of unsupported functionality, unsupported by the C# node functionality. That is still under development, so it's just there. It also has paging for get NAP 11 transfers and get NAP 17 transfers, and a lot of different extension methods. I will explain it later. Just read the documentation about that. And if it's a Neogo server we are interacting with, we will use, for example, some extension methods. That is here is the example. Yeah, the example of NAP 17 paging, transfers paging. Our client has get NAP 17 transfers method that allows you to specify start, stop, timestamp, the limit, and the page. And we have it because there can be really a lot of NAP 17 transfers on the chain for a single account. And this is the tool that allows you to retrieve all of these transfers step by step, page by page. Yeah, and here we also have getBlock system fee as an example of extension method invocation. Well, as I have already said, all the methods are well documented, and just check the extensions of our server to be aware of them. And also, what else our dApp should able to do? It is, of course, WebSocket client and server. It is another extension of Neogo. The Neogo RPC nodes support WebSockets. The server accepts the WebSocket connections on the address of this kind. You have WS in the start of the address, and you have WS in the end of the address, and just another everything else is just like simple HTTP requests. And you can use WebSocket server and WebSocket client to perform regular RPC requests, RPC calls over WebSocket. What I mean is that every simple request we have discussed earlier, for example, get version, get block count, get block by index, and etc. All these requests will work over WebSocket server or over WebSocket connection as far. And to perform these requests over WebSocket connection, you have to use WebSocket RPC client. Yeah, it is provided by the NeoGo package as far. And why you have to use it? It's just faster. WebSockets are faster, and you can just not only they are faster, but you can just also use additional extensions provided only via WebSockets. And one of these extensions is a notification subsystem. But we will talk about notification subsystem later. And now let's just take a look at the way how WebSocket client can be created. And here is the code snippet you can use to create the WebSocket client. You have to, we have new WS method that creates WebSocket for you. It is also well documented. Everything is there. And you have to provide the context to it. And here we see that this context is cancelable. We can cancel this context, and we can use this to gracefully stop the WebSocket underlying connections and some work that WebSocket client makes for you. You have to provide WebSocket endpoint, and let's see how they differs from the RPC endpoint. As I have already said, a simple RPC endpoint has HTTP prefix, and here we have a WebSocket prefix, and in the end we have the WebSocket this suffix. Yeah, let's move on. And additional options that accepts the WebSocket constructor is close notification channel if no. And this option connected to the way how our WebSocket client works, and how it manages the underlying subscriptions. But it's kind of advanced option, so you will probably read about it in the documentation. Yeah. And now after we have created the WebSocket client, we can perform initialization. It also needs to be initialized. If we see it's the same, it's an initialization method that RPC client has under the hood. And after that, we can perform some, for example, some simple RPC methods over the WebSocket. For example, we can get the contract state, which is a simple RPC method. Get contract state by address or by name, which is the NeoGo node extension as far. And here we are trying to get the gas contract state, gas token, and after that we can interact with it. For example, to get we can get its ID, we can check its new executable file, or manifest, or hash, or something else here. And also, I would like to show you some useful package that can be used to unwrap the results of invocations. Here we see that we call invoke function method, RPC method on our WebSocket client, and invoke function performs here the documentation. Invoke function performs test invocation of the function that you have provided and of the contract that you have provided. And here we like to perform test invocation of method decimals, of the gas contract. It doesn't accept any parameters, but if they are, you can provide the parameters right to the invoke function, and it also doesn't require some specific witnesses. That's why we don't have to provide signers, but you probably you have this ability to provide signers via invoke function API. And the resultant of invoke function is, as you can see, is invoke structure that is located in the Neo RPC package. I have already told about it. And invoke structure contains some invocation information, test invocation information. For example, the gas consumed during the invocation, the script itself that was invoked. The script is created on the server side because invoke function just provides method and parameters and signers to the RPC server. And the server itself creates the script that contains system contract call, interrupt call. And invoke result contains a set of various fields that can be useful during real transaction creation or some further processing. But we are interested in stack. We are interested in what in something what lies on the stack after decimals method call. You probably know that gas contract is an app17 contract, and it is required to have decimals method that returns an integer value. That is the contract decimals, yeah. And to retrieve this integer value from the stack, of course, we may manually check the stack length. We may just afterwards retrieve the first stack item that lies on the top. After that, we can check that it's integer value, and after that we can retrieve big int from it. But this is quite routine work that you don't have to perform, and we provide an unwrap package for you for this routine work. For example, unwrap begin performs that work for you. You provide the results invocation and the error. If so, it checks whether it contains whether the result was successful. Check result of checks that that the resulting state wasn't false, and it checks the stack length. It retrieves the first stack item, and afterwards it tries to retrieve an integer value from the first stack item. And all of this is inside the begin method. So use this package, use this unwrap package to perform to parse these test invocations and to make your life a bit better. And it's very convenient to use the unwrap package, the unwrap API right after invoke something, invoke function, invoke contract verify, or invoke script. Yeah. Also, it's actually not the whole point of the WebSocket client, not the only point of the WebSocket client. The main advantage of the WebSocket client is that it supports the notification subsystem. We have already know about it, and basically, notification subsystem is an Neo server extension that contains two extra methods. These methods are called subscribe and unsubscribe. our RPC server is able to manage the client subscribers and to perform some to give them some benefits, some support the underlying the socket connection with these clients, and it allows to subscribe for various events that can happen into the blockchain. For example, you can subscribe for new blocks, and then after that, your WebSocket client will receive events about new blocks addition into the chain over the WebSocket connection. Or, for example, you can subscribe for example, for new transactions or for notifications that have been generated during transaction execution or during block persisting script execution. Yeah. Or, for example, you can also subscribe for notifications that that were generated during script execution. For example, for transfers notification of some specific contract, or for notifications that were emitted by some specific transaction. Actually, there is a lot of filters here that you can use, and well, just read this documentation. It has a lot of useful features, and it even has a separate documentation page, the notification subsystem. Yeah. And here we can see the subscription management page, and the notification subsystem, as I have already said, it basically represented as two methods supported by NeoGo server and by NeoGo WebSocket client. These methods are subscribe and unsubscribe. Here goes the description of notification that RPC server can send you after subscription. Each notification has its own structure with some fields that are related to your subscription. And here is the code snippet that demonstrates how to use our notification subsystem with the NeoGo server. First of all, we should make a set of channels. For example, in this code snippet, we are going to subscribe for blocks, for notifications, for application executions. And to receive all of these notifications, you have to create a separate channel for each of them. And in a separate routing, we run the notification dispatcher loop. We have to read from these channels. And the notification dispatcher is basically manages the reads. Yeah, it reads from the block channel and writes some blocks, just logs some blocks that were received. It also reads notifications from the notification channel, and also it just logs these notifications. It reads the execution result from this channel and logs them as far. And after that, if the context provided to this dispatcher is done, it just returns from this loop. And you have to carefully, of course, you have to carefully finish the dispatcher loop. You have to drain all these channels. It's important because that's the way how WebSocket client works. It will be blocked if if our client can send the subsequent notification to the channel, it will wait for the channel to be free to send this notification. And you should know that not only the notification-related functionality will be blocked by WebSocket client, but also even standard RPC requests won't be answered and will be blocked if any notification stays unread. Thus, it's important to properly drain these channels. And this was a separate routine that reads the notification, and the main part is the routine that will send notifications to these channels. This routine is inside the WebSocket client, and to start our subscription, to start listening our blogs, events, and executions, we have to perform subscribe call. And to perform it, we have a separate API in our WebSocket client, and it calls receive blogs, receive execution notifications, and etc. Receive something basically. Well, here we have a set of APIs for different kinds of subscriptions. And after that, we have received for blogs, for notifications, for executions. You see that we have filters that receive methods accept. For example, receive blogs accept blog filter, and we can filter out only blogs from specified primary node, for example. The primary node has index 0 here. For example, we need to receive blogs from 0 validator. And for example, we need to receive blogs only till some blockade. And for example, we need to receive the first 5 blocks from the current head. And all of this you can provide to the receive method via filters. We have filters not only for the blocks, but also for notifications. You can filter them by the contract or by name. And for executions, you can filter them by state. And for transactions, actually, and for the rest of receive methods. They all have their own filters. And after we have received to the events, we have the main loop that performs some action in your dApp. Well, it just wait for 5 seconds. It handles all the notifications, and after 5 seconds, it sends the stop signal to the notification dispatcher and exits all notifications. And after exit, you also don't you have to not to forget to unsubscribe from the from your subscriptions, from all of these events you have subscribed to. And to unsubscribe, just perform unsubscribe call and use as a parameter the subscription ID that you have received as a result of subscribe method. Here we received them. And you can also use unsubscribe all API that will unsubscribe you. Here it is. That will unsubscribe you from all events that you are subscribed for at the current moment. And that's all. That's how our tiny example of subscriptions work. And let's take a look at it. How let's just run our dApp program, and I will show you how it works, how our subscriptions work. Here we see that there are some blocks I have something else in the log, but let's take a look at the log of our notification subsystem first. Here we can see that application execution result was received, the container, the trigger, and here we see the result of block on persisting script. After that, the notification about post-persisting script is received. And after that, the notification about transfer execution was received. And this is the guest transfer to the node that was accept this block. And finally, here's the notification about block. The block was received with the specified index, with the specified primary. This block doesn't contain any transactions. And after that, the same logs repeat again and again. Here we see the next block and the block after it. And in the end, to show you that this notification, that our filters work as expected, we see, the last block that is received after 5 seconds. Basically, 5 seconds, 5 blocks. Yeah, this is the setting of our single node. You can see that the order of notifications is always the same. Firstly, it is execution notifications, and after them it's block notifications. And actually after the block notification is followed by blocks transactions, but we didn't subscribe for the transactions. That's why the block notification is the last one in this row. And the order of notifications is stable, and you can read about it in our documentation. Ordering and persistent guarantees. So pay attention to this part of the documentation if you need to use it somewhere. And now, after the notification subsystem, we will go to the more interesting topic, is the upper level packages that NeoGo provides you. Actually, you don't have to use any of these simple RPC methods that RPC client or WebSocket client provides you, because we have a very powerful packages that are called Invoker and Actor. Let's take a look at them. They are also well documented, and the documentation is located in the package code there. Package Invoker provides you functionality to perform test invocations via RPC. And actually, Invoker is almost everything you need to perform some test invocations without paying. And let's take a look at the way how Invoker can be used. First of all, you have to create WebSocket client, and after that, you will provide this WebSocket client to the Invoker constructor. Constructor accepts the client and a set of signers that will be provided to the test invocations. And as a set of signers, you see that here we use our account from the wallet, and it's not even an account; it's just a script hash and a proper scope. And I would recommend you to read the article about witnesses and witness scopes in our Medium. That's Medium profile. I'll post this link afterwards, after the workshop. After Invoker is created, you can use some APIs that it provides to perform calls. And let's see what the APIs are. Yeah. You see that we may perform call of some contract of some specified methods and provide some parameters to it. We can call and expand the iterator, and this method I will explain later about how this method works. We can run some script. We can invoke verify and perform verification of some witness, some contract. And well, basically it's call, run, and verify. Let's see how it works in practice. And for example, we'd like to perform test invocation of method transfer of the gas contract. Here we have invoke your call method call, and we provide the gas transfer hash. The hash is taken from the gas state, and the gas state is taken from the get contract state RPC call we performed earlier. And the operation is transferred, and the arguments are from to amount and data. These are standard NEP17 compatible arguments of the transfer method. The call doesn't create a transaction. It performs just a test invocation, and the result of this test invocation will be either true or false exception maybe. But if everything goes well, and invocation will be halted, then we will get Boolean value on stack, and we can unwrap it. And afterwards, we can see what will be the result of transfer 5 gas from our account to some random account without any arguments. Let's see what the result. I have it logged into the console transfer result, and here it is. Transfer result is true. So test invocation returns true. And after it, let's see how historic functionality works. We have discussed it earlier, but then let's take a look at the API we provide to perform historic invocations. We have separate historic invoker, and we have a separate constructor for it. Use new historic at height to create a historic invoker at the specified height. And after this, you will all the test invocations that will be performed by this invoker, by this historic invoker, will be made with this height, at this height of blockchain. And here we provide the previous block from the block when transfer was performed. And historic invoker is able to perform exactly the same calls like simple invoker has. Here we can see a simple call, verify call, and run call. And let's call the same transfer method, but only at the height of the previously of the specified block. And the result I would expect from it is false, because by the moment of this block, we don't have any funds in our account, because the transfer transaction will be accepted only in the next block. And here we can see that transfer historic result is really false. Yeah. And another example of historic invocations can be historic balance of. Basically, this historic invocation will allows you to check your balance at some previous point of you, at some previous block of the chain. And you see that in this block we have no zero gas on our account. And also, here's that's all about the historic functionality. And I'd like to show you here that the way how we can manage events. And for example, here we have transfer event. We have a special structure provided by NAP17 package. NAP17 package is also a part of our RPC client. And for example, here's the result of invocation, of transfer invocation, you see, yeah. And this invocation contains not only the resulting stack, but also events emitted by during the transfer notifications, yeah. Here, to parse the notification, we have to read the stack. We have to go through all of these stack items and try to convert first stack item to from sender account, and after that to try to convert the second stack item to the receiver account, and after that try to convert the first stack item to integer to the transfer amount, since it's transfer event. And we also don't have to forget to check the event name, because it should be transfer event. And actually you can safely skip all of this painful unwrapping, because Neogo offers you automatic offers you a set of packages that do this for you, do this manual work for you. And I will show you them afterwards later, but now let's take a look at the set of other invoker methods. Yeah, here they are. They are also well documented, and just use them to perform test invocations in your dApp. And test invocations are good, but it's not the whole point of your dApp. Your dApp probably should be able to send some real transactions to the network, and to perform it, you will probably use a Nectar package. Nectar package is another RPC client package that provides you a very powerful API to build the transactions, to call contracts, and to send these transactions to the network. And let's take a look at the way how Actor works. And here, the first difference from Invoker, you can see that we provide actual real signers, real accounts to the actor. It is needed because the actor is going to create real transactions, and to sign them, and to sign the transaction, you need the decrypted account. Thus, we provide some a real account that is decrypted. It was decrypted earlier. And we also provide a signer that will be used to sign all of the transactions emitted by actor. And the signer is the same signer as we used for Invoker. And to create actor, you need a WebSocket client and a set of signers. And it's very simple, and afterwards you can use it. You can use actor to send some transactions. And let's take a look at the way how transactions can be created. And actually, these 4 lines, even even these 2 lines are all that needed to create, for example, transfer transaction or any other transaction to the network. First of all, Actors has a set of APIs that are called send call, send run. Let's take a look. Yeah, we see that there are send run, the send call, send to send simple transaction, send call to send transaction that involves specified method of the specified contract, send run to send a transaction that contains specified script. And let's check how send call works. It creates transaction that calls transfer method of guest state, but it may be any other method of any other contract that sets any parameters. You can simply provide these parameters to the send call and as variadic args, and it will work. We support almost all types of the parameters. If something is not supported, just submit an issue to the NeoGo repo and we will support it as soon as possible. And after that, nice part of the actor that it provides the API that can that will wait for your transaction, and it calls actor wait or maybe actor waiting. Wait, yeah, we have two methods, wait and waiting. Wait will wait for a single transaction, and waiting will wait for a set of the transaction to enter the chain, to enter some log. And wait will do all the work for you, and wait until the transaction will go from the mempool to some consensus node, and will go to the chain afterwards. And after that, you will receive just the application execution result with the virtual machine state, the resulting state, which, we expect it to be halt. And with some stack, the resulting stack, yeah, we can check the stack afterwards. We can also check the, for example, script container hash. We can also check events that were emitted during this transaction execution, and etc., etc. And all of this is just 2 lines, which is very, very good. We really recommend you to use this actor to send, to sign and send your transactions. But it's not the whole functionality that actor can provide to you. Actor can actually send some tuned calls. For example, if you are not satisfied with just simple transfer call and you need to tune the transaction parameters that will be emitted after transaction, after test invocation, that actor will fill for you. You can use send tuned call, and we have actually a set of send tuned run for running a specified script, or send tuned call and send tuned run, basically these two. What we can do here is to modify the transaction after actor will create it for you. First of all, we can add some additional attributes to this transaction, or we can, for example, modify network fee value, or we can check that stack returned from test invocation of the script contains specific items, and if it doesn't contain them, we can return an error and stop the transaction creation process. And basically, you can use it to change the network fee, for example, to make it bigger. Yeah. And by default, send tuned call, you can see that I wrote here default checker modifier, and this checker modifier is used as default one in send call, actor call. Yeah. And if it's not enough for you, and you need to create some special transaction that contains some unexpected some values that need to be tuned better than this, and this API is not enough, then you can create a customizable actor. And for example, it can be created with actor new tuned method. yeah. You can see that it accepts the same RPC actor, signers, and options that will be used to modify the transaction made after test invocation of your script. And you can provide some additional attribute to by default to your actor. You can provide checker modifier by default that to your actor, and after that actor will apply this checker modifier to all the transactions that will be emitted by the actor. And you can use the modifier, custom modifier also. Just read the documentation and try it out by yourself. It's very extremely powerful API that can be used to create different transactions. And also, if you probably another thing that is worth to mention, if you don't need to send the transaction immediately, you can use API, actor API that allows you to construct the transaction but not send it. For example, send. Yeah. For example, run. You can run the script. It's the method nested from the invoker. You can sign the transaction, sign and send the transaction, and well, basically it's very powerful API. A set of other actor methods are documented in the package go-dev, and use this documentation while creating your dApp. And that's all about actor. And now let's talk about more specific packages that Neogo provides you. As you see, we have discussed earlier only invocation of some common methods of any contract, but we have a set of packages for NAP 17 compatible contracts and NAP 11 compatible contracts, and this package is called NAP 17 and NAP 11 correspondingly. To create NAP 17 specific actor, it's also actor, but with some extra API that are specific for NAP 17 tokens. You have to use the constructor and provide the simple actor to the constructor and the hash of the NAP 17 compatible contract. In this example, it's GES contract, native contract, but you can provide your custom contract hash, and all you have to do is to check that your contract is really NAP 17 to use this package. And after that, you can see that this sector provides you API that is declared by the NAP 17 standard. It has decimals, it has balance of method, it has symbol and total supply methods. It also has transfer methods, but which is better? This NAP 17 specific package, like NAP 11 specific packages, they have multi-transfer API that allows you to send multiple transfers in one transaction. For example, here, multi-transfer is called and it accepts a set of transfer parameters. This is the parameters of the first transfer. We'd like to transfer from our account to back to our account, 5 gas. And the second transfer is we'd like to transfer from our account to some random account, another 5 gas. And all of this will be performed in a single transaction, and we will wait for this transaction, wait for it to be set to the chain, and just check the error. Yeah. And after this, you can after this, you can retrieve transfer events from your transaction by just using one line of the code. We have special get application. Not sure. Yeah, we have special transfer events from application log method. It's helper, and it is located in the dApp 17 package or in dApp 11 package. And it allows you to skip all this manual work we have done earlier to parse the transfer events. So just use it to parse dApp 17 transfer identifications or dApp 11 transfer identifications. Yeah, and in our log, we can. What happens? Yeah, in our log, we can see that these events are successfully retrieved by the call by transfers from application log call. And here are parameters from, to, and amount. You see that from and to are the same account. It's the first transfer, and from and to from it's our account, and to is another account, and 5 guess was transferred from our account to somewhere else. And moreover, after these dApp-specific packages, we provide a set of native contract-specific actor packages, for example, guess or policy. And these packages contains a set of methods that are specific for native contracts. For example, for guess contract, we can create an actor, and yeah, this actor has basically it has the same dApp 17 functionality, because guess contract is dApp 17, just a dApp 17 standard contract. But more interesting is that we have for example, for policy contract, and policy actor allows you to get fee per byte, exact fee factor, and all the storage price, and all of this is just simple. All of these methods are simple Go methods that can be invoked via this API. Yeah, and we have here we are in the RPC client package. We have wrappers for guess, for management contract, for neo contract, for neo name service contract. Well, the Go implementation of neo name service, because there is actually no native name service contract, and we have its own implementation in our repository. And we have wrappers for policy contract, for role management, and everything is for you. Just use these APIs to build your dApp, to retrieve some useful values, to use them in your dApp, and to perform some useful invocations. Actually, all you have to know is these 3 points: the invoker package, the actor package, and these custom wrappers for dApp compatible tokens and native contracts. Yeah, all of them you can find in the RPC client, under the RPC client package. And after that, I would like to show you, well, it probably will be the last part of our workshop, the last and the most meaningful one, how to deploy contract, how to invoke it using actor, and how to actually automatically generate all of this code that I have just showed you. And let's try to deploy some contract to the chain. And firstly, we will deploy a very simple contract. It calls storage. It's in our examples, but I have slightly modified it. Here it is. The storage contract is very simple. It provides an API to put something into the storage, to put some value by a specific key, to put the value by default key, to get some value, to get the key stored by default key value, and to delete an item. And it also provides two methods that allow to find some value in the storage, to find the set of key value pairs that are stored, and those value matches the specified prefix. And the last method, which will be used by us, is a find and return iterator. And this method allows you to retrieve storage iterator over values with the specified prefix. So basically, it's just a simple contract that interacts with the contract storage. And we will firstly compile it, and after that deploy it to the chain using actor. To compile it, we will use Neogo CLI, and the steps are very simple to the steps that we have discussed in the previous workshop. And let's just compile it. It's Neogo contract compile command. And after that, we have manifest.json and storage NF files that are generated by the compiler. And then we can deploy this contract. Let's see how it can be deployed by the Go code. To deploy the contract, we have to invoke deploy method of the native management contract. And to be able to invoke native management contract, we have to create a management specific actor. Let's create it. We have this management wrapper I told you earlier about it, and just invoke new to create a management specific actor. And here it is, and it has all the methods management contract provides to you. It's deploy transaction will create transaction but not send it. Deploy inside will create a transaction but will not send it and will not sign it. And we have a set of other methods that management provides to us. It's get contract, the get contract by ID, get contract hashes, and everything else, set minimum deployment fee, everything else that needed to deploy the contract and manage your contract basically. And after that, to deploy a contract, you will need contract NF and contract manifest files. Just read them from the specified directory, from the storage directory, or from whatever you put these NF and manifest files before. So here we read NF, we read manifest, and here additional check present. This check is about it checks whether the contract was deployed earlier, and it's here just to be able to run our program several times, and just so that we will just skip this check. And the contract, how to deploy it, we simply call the management deploy method, management actor.deploy, and provide NF file to it and manifest file to it. And if your contract accepts some additional data on deploy method, just provide this data as parameters to deploy call. But our contract doesn't have the deploy method, well, thus, it doesn't accept anything on deploy. It's just provide new here. And wait for the transaction to be persisted. And after that, we can check the stack of the deployment transaction. This code is here just to show you how we can work with stack and how we can retrieve the hash of deployed contract from the resulting stack. You don't have to perform it every time. And after that, we will put several values into the storage of the deploy contract. How to put them is create a transaction, send call. We call the our contract, it's hash, and we call method put on this contract and provide key and value of these storage items. Here we put several values to the contract storage. And after that, when we deployed and invoked our contract, we have to, we will search these values in the search for these values in the storage. And to do it, we will call a find ret iter method. Yeah, let's see. As you remember, this method return iterator over the contract storage, and iterator is just an entity, just a storage item, interop interface on the stack. Thus, if you will call this method, you will get just an interop interface on the stack. But what we actually want is to check all these storage items that have key prefix. And there are several ways to do it. And the first one is to create a script that will iterate over this iterator values and store all of them in the stack. And we actually have the script, and it is inside the call and expand iterator API. This call will create this script for you. If we go deeper, it works with some VM instructions and performs all this magic for you. And all of this is just to expand iterator. It has some constraints. Just check the documentation, but basically this method can be used if iterator sessions are disabled on the RPC node you use. This method can be used both on the C# node and on the NeoGo node. It will just send this script to the node and check and return an array of iterator items at this stack. And after that, we use unwrap array to unwrap the array of storage items. And after that, we just bring these storage items into the console. And let's take a look at what our storage iterator has. And here is the log. It has 3 values: K1 value 1, K2 value 2, and K3 value 3. Late in the storage, so everything works as expected. But actually, we do not recommend this way of retrieving iterator values from the storage because it is very constrained. And if there is a possibility to use iterator sessions, we recommend them. We recommend you to use them. And to do it, we have a separate API that is able to actually to work with iterative sessions if, of course, they are enabled in the RPC node you're querying for. And for example, to enable them in our RPC single node, I have to slightly change the default config we provide. And here we have protocol prenet docker single configuration. It is a NeoGo node configuration file. And here we just add this line to the RPC configuration to enable iterator sessions. And in C# node, RPC node, you have to provide additional config to enable sessions as far. And well, just check the node that you use as an RPC and ensure that sessions are enabled there. And if they are, then you can use this iterator API that is provided by Actor package. And let's perform call, and call will create transaction that calls this method and nothing else. This method will return iterator, and sessions are enabled, so it returns this session ID and iterator ID as the interop interface stack parameter. And to unwrap this iterator, we have unwrap session iterator helper. It will retrieve the session ID from the resulting stack item. And here you can use this session ID and iterator ID to perform some steps through your iterator. And we have a separate API to be able to traverse iterator, and it's in the actor as far, and it calls traverse iterator. You have to provide session ID and iterator itself, iterator ID to this API, and the desired number of items you'd like to traverse through. For example, these 2 items. And it just performs the iterator traversal for you and returns iterator values that are stored. And here we just log them, and we can see what is printed in the log is these 2 items as expected. So everything works well, and just use this API if sessions are enabled on your RPC server. And after that, we have to not to forget to terminate iterative session. It just makes let the server, the RPC server, know that your iterator session isn't needed anymore, and RPC server can close it. Yeah. And actually, after that, now we know how to deploy the contract, how to use actor to invoke this contract, how to use invoker to perform test invocations of this contract, and we know how to work with iterators if there is something. And now I'd like to show you how to use NeoGo bindings generator, RPC bindings generator, to be able to generate all of this code, not by yourself, but by the means of NeoGo. Let's perform the generation. In the start of this workshop, we have generated the simple wrappers for the contract. And RPC wrapper is slightly different thing. It allows you to invoke your contract not from another contract, but from your dApp code. So you can use the resulting wrapper as a helper in your dApp, and basically the resulting wrapper will be look like native specific wrapper packages I have shown you earlier. And let's take a look. To generate RPC wrapper, you have to firstly compile your contract. Let's compile it. And don't forget to specify bindings flag to be able to provide additional information retrieved by Go compiler to the resulting bindings. With this flag, your bindings will be more complicated and more useful. And after that, let's use the contract generate RPC wrapper command. It accepts as an input the configuration file that was generated earlier during compilation, and it accepts the contract manifest, the output file, desired output file for bindings, and contract hash. The hash actually can be omitted, but we know this hash, and we can provide it. And now let's take a look at the output. It should be RPC wrappers, RPC Go, and examples, storage, RPC wrappers for our storage contract. And let's take a look Yeah, good. What we can see is a separate package that contains an actor. And the valid until block value. And so you can use the same actor API to wait for this transaction. After that, we have a set of methods. For example, delete transaction will create transaction that calls delete method of the contract, but not sends it to the network. Delete unsigned will create the transaction that calls delete method of the contract, but not send it to the network and not sign it. And we also have the same methods for a set of other contract methods, for example, find and find return iterator method, and get the second get method that is get default. That's marked as get default here, but in the API we have specified in the config that get default method should have name get, so it's overload. And we also have the same API for put method, and actually now you can use this package from your dApp code and easily invoke this contract without writing any line of code. Yeah, let's see. I have some prepared codes for it. Yeah. How to create this actor, this contract specific actor? Call the constructor, and the constructor is called u. So we have storage contract u, and here it is, the constructor that creates a contract structure for you that can be afterwards used for invoking all of these methods. And after that, you can perform the same things that we have performed earlier, but for your contract. See how it's very easy, and you just specify storage contract and see what it can be done. You can invoke delete, you can invoke find, get, anything that your contract offers you, and all of this is provided by the NeoGo bindings generator. So use this bindings generator. It's extremely powerful tool that allows you to omit a lot of manual work while writing code for your contract, invocations. And actually, what I'd like to show you in the end is the example of more complicated contracts. We have NeoFast contracts. I have already told you about them in the start of this workshop. These are Go contracts that currently are running in the NeoFast, and we have automatic RPC bindings generated for them. And I have already shown you in the start of this workshop how to generate bindings for them. It's written in the README file in NeoFast contract repo. And here, for each contract, we perform this command, generate RPC wrapper. We provide the same options as for our storage contract, and let's take a look at the resulting bindings that are generated automatically. They are located in the NeoFast contract repository. under RPC package. And for example, let's take a look at the alphabet contract binding. You see that it has more than 1,000 lines of code, and it's quite a big one, but it provides a lot of functionality for you. First of all, here we can see structures that are used by this contract, and these structures are real goal structures, although in the contract they are implemented as during contract execution, all of these structures are implemented as stack items, and RPC binding generator make it possible for you not to write these events manually, but just to use them. And what we have for this, there was generated a method from stack item that allows to convert this structure from stack item and return an error if so. After that, after all of these structures, we have what we have. Yeah, we have two interfaces defined. It's invoker that allows to invoke to perform test invocations of your contract, and invoker is defined is needed to create the contract structure, and the actor that is needed to perform some actions to perform real transactions for your contract. And here it's the resulting contract reader structure that allows you to perform test invocations of those methods that are marked as safe for this contract, and contract reader won't send the transactions, but instead it will send test indications and perform just perform test indications over this contract. And the second structure is the contract. Actually, it's the structure that you will interact with in your dApp, in your dApp API. And we have two constructors. A new reader creates a contract reader, and new creates an instance of a contract, but you actually probably will use this one, and this constructor will create you a contract. And after that, you will just interact with your contract via this API. And for example, here we have update method, and here we have vote method. An alphabet contract have vote method. Here it's an API to call this method and to send the transaction actually that calls this method, or to make a transaction that calls this method, or to make the transaction and not sign it. And what else we have here? We have that, we have these structures defined, we have these constructors, we have, firstly, we have safe methods defined on the contract reader. It is gas, name, neo. All of these methods can be invoked, can be test invoked. After that, we have methods that require transaction to be called. And after these methods, we have additional helpers that I have shown you them already. These helpers allow you to convert the result of invocation from stack item, and you can invoke them to parse the resulting stack of the test invocations after actor wait call. Yeah, after exactly like we did here. Actor wait, and after that you'll get the stack, and you can call these helpers to parse items from this stack. And these helpers are for all generated structures that your contract uses. And also you have set of events that contract emits. Let me show you events. Yeah, for example, here we have a special structure. It is called management event. It is defined after somewhere in the start of this file. And management event is emitted by probably by the management contract when the contract is deployed, because Alphabet contract uses deploy method. And let's check. Yeah, here's the deploy methods, and well, these events are emitted and also have from stack item helper, but you can use this helper while retrieving notifications from the notifications field of the resulting application execution result. Yeah, and all of we strictly recommend you to use these helpers, and don't hesitate to read the documentation, to ask the questions about it, and because it's extremely powerful feature, who provides to you. And actually, with this automatically bindings generator, you don't even need to write the code by yourself. You just have to run two commands, and this API is made for you and ready to be used in your dApp. And all of these things we have discussed in our dApp example, they actually can be skipped and just go to these two lines and use the automatic bindings. But also for not complicated tasks, all of this can also be used in the sector and invoker and etc. And even RPC client can also be used if needed. So we are welcoming you to use our SDK for contract developing and for dApp developing. And well, I think that's all that I'd like to tell you. And as a summary, I'd like to mention that all these RPC bindings can be generated not only for Go smart contracts and not only for contracts that are compiled by NeoGo compiler, but for any contracts that are written in any languages, for compiled contracts that have NEF file, that has manifest file, just provide just provide the corresponding manifest file, and the bindings will be generated for you, but not as they won't be as useful and as complete as if when you use when you use it with a NeoGo compiler, because NeoGo compiler generates additional information stored in the bindings configuration file. Yeah, and what we have for our future development is proposal with this extended manifest data types. It can be found in the proposals repository of Neo project, and these proposals will make possible to generate these bindings for any contract that has this extended type specified in the contract manifest. And I hope that this proposal will be set soon, and we then will be able to support these very powerful bindings, fully support them for each Neo-compatible language. And it's really cool because well, it makes the development process easier. And actually, almost all of this functionality except the extensions I have mentioned earlier, you can use with NeoGo backend and with Neo C# node. But using NeoGo RPC node as a backend will allow you to get a large set of advantages and features that are not available, for example, from the RPC C# node. And the last note I'd like to mention is that everything I have shown you is made on the latest master, and the latest master isn't released yet. The latest release we have is 0.101.3. And this release doesn't include some features that's for example, events generation or some compiler fixes, latest compiler fixes, but we hope that the next release will happen very soon. The next release we expect is 0.102.0, and it will be 3.6 compatible. Which means it will be compatible with the C# node release 3.6. Yeah. So we expect this release soon, and stay tuned, stay with us, use our APIs, use our functionality to build your dApps and to build your contracts. Thank you for joining us today. Yeah.